Hi, this is Hilal. In this video on Mathematical Economics series, we will solve a numerical on finding the degree of monopoly and finding equilibrium quantity and advertising cost from a given demand and cost function. The question is like this. Assume that a firm in a monopolistic competition faces the demand and cost function. We are given the demand function which is equal to, that is P is equal to 100 minus 3Q plus 4 A to the power 1 by 2, okay, where Q is the quantity and A is the advertising cost, and TC is equal to, that total cost is equal to 4Q square plus 10Q plus A, where P is the price and A is the advertisement. Okay, we are supposed to find the equilibrium quantity and advertising cost, and second part tells us to find the degree of monopoly. Okay, so we will see how to solve this very question. Now, first of all, what we have to do, the first step is to find the profit function. Okay, as we know, profit, I will denote it by pi. Profit is simply equal to total revenue minus total cost. Okay, when we deduct the total cost from total revenue, we get the profit. Now, total revenue, as we know, is simply equal to price times quantity. Okay, now our price function, which is the inverse demand function here, price function is given. So in place of P, I will write this very demand function, that is 100 minus 3Q plus 4A to the power 1 by 2, and to it I will multiply this very Q. Okay, which implies, so since this Q is multiplied to each term, so we will multiply it to every term, that is 100 Q minus 3 times the Q into Q is Q square plus 4 Q A to the power 1 by 2. This is our profit function. Sorry, this is our total revenue. Now total cost is given. I will not write here to save some space. So total cost is given. Therefore, our profit function would be simply equal to total revenue, that is 100Q minus 3Q square plus 4Q A to the power 1 by 2, that is equal to total revenue minus total cost, which is this very function. So this is minus, all these terms will become the negative. So this is 4Q square minus 10Q minus A. This is our profit function. Now, as we know, at equilibrium, the firm wants us to choose the level of output and advertising in such a way as to maximize its profit. That is, profit maximization requires, there are the first order condition for profit maximization is, that is, first order condition for profit maximization requires, we have here two sub first order conditions. First order condition is I would rather say there are two conditions in first order condition. First condition is that the derivative of profit function with respect to quantity should be equal to 0. Okay, and second is, so first I will write this very equation. So that means we have to differentiate this very profit function with respect to quantity. Okay, the derivative of Q is 1 by power function rule. So we are left here with 100, okay, minus derivative of Q square is 2Q. So 2 into 3 is minus 6, minus 6Q plus derivative of Q is 1. So we are left with 4A to the power 1 by 2, that is 4A to the power 1 by 2 minus derivative of Q square is 2Q. Now I am saying Q square, its derivative is 2Q. Okay, so now 2Q into 4 is equal to minus 8Q, and here also the derivative of Q is 1, so we are left with minus 10, and it should be equal to 0. Second first order condition requires, that is, the derivative of profit function with respect to advertisement should be equal to 0. which implies we have to differentiate this very profit function with respect to a, which is the advertisement here. Okay, so since in the first term no a is involved, so derivative is 0. Here no a is involved, so derivative is 0. Here a is involved, so the derivative of a to the power 1 by 2 is, we have a to the power 1 by 2. Its derivative is simply we take this exponent and form it as coefficient, so this will become 1 by 2 a, and from that exponent we subtract 1, that is 1 by 2 minus 1, because power function rule says if we are have to differentiate x to the power n, it is derivative is simply we take this n and form it as coefficient, and this exponent is subtracted by 1, that is n minus 1. This is the rule which we apply here. In place of n we have here 1 by 2, and using this very method we get the required result. Okay, now uh, that means a to the power 1 by 2 is simply equal to 1 by 2, its derivative is 1 by 2 a to the power. Now 1 by 2 minus 1 is simply 1 minus 2 divided by 2, that is minus 1 by 2, so we will get minus 1 by 2 as the exponent. So we were at this term, so this is 4 times the derivative of q is, since we are differentiating partially with respect to a, so q will remain same, times 1 by 2 1 by 2 a to the power minus 1 by 2, and since no a is involved in this term, so derivative is 0. Here the derivative is 0, the derivative of a is 1, so we are left with minus 1, and set it equal to 0. Here we can cancel these two, so we will get here 2q a to the power minus 1 by 2 minus 1 is equal to 0. Okay, so let me rub this out, which implies here what we can do, one thing, 2q a to the power minus 1 by 2 is equal to, transposing this one on RHS, this will become positive 1. Okay, or we can write here 2q, now a to the power minus 1 by 2, a to the power minus 1 by 2 can be written as 1 divided by a to the power plus 1 by 2. This is the law from the basic algebra, that is x to the power minus n is equal to 1 divided by x to the power plus n. So I am just using that very function, so this will become denominator a to the power 1 by 2, and it is equal to 1. Okay, so here we can write it like this. We can write this is 2q, or I will write a to the power 1 by 2, a to the power 1 by 2, we are cross multiplying, is equal to 2q. Okay, so we will use this very relation. Now what will we do, we will put this value, put, and let this be equation first, and let this be equation second, let this be equation second. So we will not write the equation second. We put a to the power 1 by 2 is equal to 2q. We put this value in this very equation, in the first equation. Okay, that means we have 100 minus 6q plus 4. Now a to the power 1 by 2 is equal to 2q. So in this in place of this we have this very 2q, okay, minus 8q minus 10 is equal to 0. Okay, now what will we do here, we can see we have here 100 minus 10 is equal to 90. So first I will write minus this is 100 minus 10 is 90, minus 6q and minus 8q is equal to minus 14q. Okay, and we have this 4 into 2 is equal to 8, so I will write 8q is equal to 0. Now 90 minus 14q plus 8q is equal to, now 14 minus 8, 14 minus 8 is equal to 6. Yes, it is 6, so I will write here minus 6 q is equal to 0. Now solving for q, we will get or I will write here to make it more simple for you, 6q is equal to 90. I just transposed this minus 6q on RHS and it became positive, or q is equal to 90 divided by this will become the denominator when transposing. So this is like this. So we get here 6 ones are 6, 7 8 9, 3 6 5s are 30. So equilibrium quantity would be equal to 15. Okay, so we got the equilibrium quantity. Now we have to find the equilibrium advertisement. Okay, advertisement cost. What will we do? We will put this q is equal to 15 in this very equation. Let this be equation 2. Put the value of put q is equal to 15 in second. Okay, now we have a to the power 1 by 2 is equal to 2 times the value of q is 15, so I will write 15, which is equal to 30, or a to the power 1 by 2 is equal to 30, or we can write a is equal to, when transposing exponent 1 by 2 on RHS, the this exponent gets reciprocated, that is 1 by 2 will become 2 by 1. That means a to the power 1 by 2 would become square here. Okay, this is from the law of exponents, that is if we have x to the power 1 by n, okay, and if we is equal to, let us say, p, and if we want to transpose this power on RHS, so this will simply equal to, this will get reciprocated. It will become, if it is if it was here 1 by n, here it will become n by 1. Okay, so same rule I have applied here. So let me rub this out. So our a is simply equal to 30 square is equal to 900. Okay, so we got the advertisement cost is 900 and equilibrium quantity is equal to 15. Now we can also find the equilibrium price. Now equilibrium price would be simply equal to, we put the value of a and q in our demand function. That means our equilibrium price would be equal to, we have 100 here, 100 minus 3, the value of q is 15, so I will write 15 plus 4, a, the value of a is 900, so I will write here 900 to the power 1 by 2. Okay, or which is equal to 100. Now 100 3 into 45, sorry, 3 into 15 is equal to 45. 100 minus 45 is equal to 55 plus 4 times the, this is simply 900. 1 by 2 can be written as under root of 900, and we know under root of 900 can be written as 30 square. This square and root gets cancelled, so we get here 4 into 13. Okay, which is equal to 55 plus 4 is 12, 120, which is equal to, 170, because 20 plus 55 is equal to 175. So we will get 175 as our equilibrium price, which is equal to 175. So p is equal to 175. So we got all the variables here. Our equilibrium quantity is 15, advertising cost is 900, and equilibrium price is 175. So coming to the next question, next subpart rather, that is to find the degree of monopoly. Okay, now how do we find the degree of monopoly? We use the learner's index here. Okay, so let me use another degree of monopoly. Degree of monopoly For that we use learners index, that is learners index. The formula is simple, that is for that we have price minus marginal cost divided by price. This is the learners index, which is used to compute the degree of monopoly. Now this shows how much of a markup the firm is charging above its marginal cost as a rather as a proportion of its price. Okay, so we can find the numerical value of the degree of monopoly. For that we need to find the marginal cost. Our total cost is given as, so I will write here, total cost is given as 4q square plus 10q plus a. Marginal cost is simply the derivative of total cost with respect to quantity. So this will differentiating this total cost with respect to q, so this 2 will become coefficient as I will show you by the power function rule. So 2 4s are 8 q, 2 minus 1 is 1, so q to the power 1 is q, plus the derivative of q is 1, so here we have only 10. Okay, since no q is involved in third term, derivative is 0. So our marginal cost is this 8q plus 10. Now marginal cost at equilibrium when price is equal to 175, our we have to find marginal cost at the equilibrium quantity, that is when q is equal to 15. Our marginal cost would be equal to 8 into 15 plus 10. Okay, this is equal to 8 5s are 30, 8 1s are 8, 9, 10, 11, that is equal to 110 plus 10, which is equal to 120. Okay, we got the marginal cost also here. Now degree of monopoly is equal to price is 175 minus marginal cost is 120 divided by price, this is 175. Okay, now when we try to solve this, 175 minus 120 is equal to 5, 7 minus 2 is equal to 55 divided by 175. Okay, if we can further find its value, so we have 5 1s are 5 1s are 5 3s are 15, 5 5s are, so we got here 11 divided by 35, and we can find from the calculator. I am not good enough at the calculation, so 11 divided by 35, so I will try to calculate here. 11, we have 35 here. Okay, let there be point here, it will be 0. Now we have 35 into 2 is 75, 35 into 3 would get more than 110, so 35 2 is equal to 70, so I will write here 70, 0. Here 11 minus 7 is equal to 4. Okay, now 35 into 5, let multiply it by 5, so 5 5s are 25, 5 3s are 15, 16 17 18. I am not sure about the calculation, but it should be any value. When you calculate, you will get any value between 0 and 1. Okay, so let this be 0.24 or any number. So we see the degree of monopoly which we got here, 0.24. I am not sure about the second decimal, but it is like 0.24, and it shows us how much markup the firm is charging above its marginal cost as a proportion of its price. Okay, I hope I make myself clear and you find this very video helpful. Thank you.